Hello and welcome to another episode of Bd&e Presents. Today I'll be speaking with Taylor Gilmore, Senior Director of Product Management, Industry Solutions at Bentley, and Tom Coleman, VP Visualization and Data Intelligence at WSP. We'll be looking at digital delivery, including the use of digital twins and Internet of Things devices and data in the design, construction, and operation of bridge assets. We'll be analyzing the many benefits of digital delivery to clients, designers, contractors, and engineers, as well as exploring the concept more deeply through the lens of one of the USA's biggest and most important bridge projects, the Interstate Bridge Replacement Program. Welcome, everyone. It's great to have such a variety of expertise on the panel today. To begin with, let's start with the statistic from the American Society of Civil Engineers 2021 report card, which is that 46,000 bridges in the US are rated structurally deficient. So how did we get there, and how might digital delivery prevent us seeing a similar statistic in 50 to 60 years?
Yeah, thanks, Khalifa. It is great to be with you here on the webinar today. I'm looking forward to the discussion. We've got some exciting things to go over. Yeah, as for the question, I think a lot of owner-operators in infrastructure and in the transportation or mobility space are facing a lot of challenges when it comes to staff retiring, reduced workforces, and really the need to be able to execute more projects and provide more safety and updates to infrastructure with less resources and less individuals doing the work. And so one thing that we're really excited at Bentley to be able to be providing into the industry is the use of digital twins and digital workflows into these transportation industries for execution on existing infrastructure and also on new infrastructure. And the term digital twin is relatively new. We are really excited about the prospects that it brings to enable users to really create a digital representation of a physical asset that's out in the field. And so a digital twin allows you to really break down data silos, federate together lots of different data into a single visualization environment, and allow users to utilize that information in the office where previously they may have had to go out in the field. And so these digital workflows are really reinventing how agencies are able to work and collaborate together, especially in this new environment after the pandemic where many users are working from home and aren't able to collaborate in person as they were previously.
Okay, thank you very much for describing the digital twin phenomenon. As you said, it's becoming familiar to many in the bridge industry, but how has its implementation and integration with Internet of Things devices and data evolved through to the present day?
Yeah, so digital twins, like I said, allow agencies to really federate together data coming from many different environments, whether that's BIM data or reality data captured with drones, as well as inspection data and maintenance data. And one of the key aspects of the digital twin is the ability to make sure that it's not a static set of information, but it's actually a living digital twin that stays up to date with the latest information that's available coming from the field. And one of the key areas that we're able to do that now is through the use of IoT or Internet of Things sensors and monitoring equipment in the field. And so that IoT data is now, there's been huge advancements made in that space to allow agencies to very quickly and easily kind of do lick and stick applications of these types of monitors on bridges and other infrastructure assets to be able to monitor things like vibration and tilt, changes in temperature and stress, and give agencies real-time information back into their office of what's happening with their assets in the field. And so when there's extreme weather events, flood events, hurricanes, tornadoes, things like that, instead of needing to send field personnel out in order to check every single one of these assets in the field, which obviously is very costly and time consuming, by having IoT sensors on critical infrastructure that maybe in high-risk areas, agencies are able to get real-time updates and alerts, letting them know if there's anything of particular concern happening at specific structures, which they can then respond to and make sure that their resources are being spent and used in the most efficient and effective places possible.
Okay, so perhaps we could delve into the use of digital data and Internet of Things devices and data across a specific project. And for that, we have Tom Coleman from WSP, who is involved in the Interstate Bridge Replacement program. Tom, could you give us some general information about this project
Sure.
and what digital delivery means in practice there?
Yep. On the IBR program, we have a understanding of what it actually is needed to encompass and implement a digital twin solution for the program. This program includes 56 bridges, 54 landside bridges, as well as the 2 main river crossing bridges over the I-5, over the Columbia River. And this aspect of this program, we are developing a digital twin solution. So as Taylor recommended or suggested, the integration of IoT into this program gives us comprehensive knowledge about the existing conditions of the bridge, as well as allows us to respond to the design challenges for the program.
Okay, and how do you envisage the use of IoT in this project across the design phase and also the design life of the asset once it's built?
Well, for this, we are working to develop a IoT strategy where we can place sensors directly on the existing bridges. Some of those bridges will look at help to look at the movement of those bridges as this area of the country is a seismic area. So again, how those bridges respond to the existing conditions or seismic analysis is important. How the bridges will be designed in response to those is also important, but also other sensors that inform us about weather, traffic, and other aspects of the program of this program area, which extends between 2 states, Washington and Oregon, across the Columbia River, are critical to the infrastructure.
Okay, and what will happen to the digital twin model once construction is finished?
Well, again, the important aspect of the IoT strategy is not just to understand the pre-construction and construction, but is also to look at the maintenance as well as the life cycle of the program. So as the program transitions through construction to operation, sensors will be an integral part of the design of the infrastructure, both from a perspective of the roadway, bridges, and other aspects of the program. So we want to be able to deliver real-time information to the agencies involved in the program. So this will allow to use a virtual twin of the program to monitor maintenance and operations of the program.
What do you see as the most tangible, the biggest benefits in using digital twin in the O&M phase?
It is a reduction in cost and in operation to those. Again, as Taylor mentioned, part of the opportunity of a digital twin solution in these tools is to produce cost savings which will be fully realized potentially in operations due to just global knowledge and statistics in this area. We expect to save anywhere from 15 to 20% alone on operations in the use of these technologies.
And could you perhaps delve a little bit deeper into exactly what kind of software you're using and how you're training and onboarding perhaps teams that aren't familiar with it in the project?
Well, during the conceptual design and through construction, and for the final design, we're using Bentley iTwins for this project. We're using Bentley Open Roads and Open Bridge solutions to develop the 3D models, the virtual models within iTwins. And we are also using other software, Microsoft's Power BI application to extract all that data from the models to look at the real-time information in the design and be able to connect sensors into that program.
Okay, that's really fascinating. So when it comes to having a network of sensors installed on bridges, I think we can all agree that that's a good thing, but how does one ensure that you make the most of such a network and integrate sensor and other IoT data into a format that can be easily analyzed and used effectively to manage a bridge?
Yep, and that's part of the planning we are doing now for the program to develop a strategic plan for IoT and sensors. Our goal really, even though we're using specific technology stacks and tools, our goal is to be somewhat agnostic to sensors. We want to accommodate all types of sensors and data tools because as the program moves into construction, there are many contractors, many different vendors involved that may bring solutions to their own workflows, as well as workflows that we specify from the program. But our goal is to accommodate a range of solutions and be agnostic to that in that interface so we can adapt to all forms of data collection and integration.
Yeah, and just to add to that, Tom, I think, it really comes down to the expertise of the engineering team to understand kind of what are the risks of the asset and the project, understanding environmental risks and placing sensors in the project area before the project so you can get a baseline of what is going on in that area. And that way, when construction starts, you have that baseline to compare back to for existing assets that are in the area. I know that's of particular interest on the IBR project, but also just understanding environmental impacts as the project is ongoing. And after handover into operations, again, being able to see the effects of that project long term on the environment and also on the traveling public and the other users of the infrastructure. But a big aspect, again, of being able to get use out of the IoT sensors in this case is being able to stitch that information together with all of the other types of data that an agency may have, which in the past may have been in disparate systems and very difficult to pull together in order to make decisions. And so the power of that digital twin enables, again, the federation of that data. And it could be, I mentioned this already, but BIM data and CAD drawings coming from design and construction, reality data captured from drones and from LiDAR scans. On the IBR project, Tom even utilized a helicopter in order to capture the entire corridor of the project, which has been extremely valuable to have that large reality data set within the project. You can also pull in subsurface information for analysis below ground and below the surface of the water, which can be extremely valuable. And then you can start overlaying, as you go into operations, additional information beyond that. So being able to utilize, and overlay maintenance information, inspection information, element detail analysis. We can even, within the digital twin environment, start to overlay the reality data with AIML defect detection. And so we can take the photographs that have been utilized, identify where cracks exist, identify where rusting or spalling exists. And by consolidating all that information into one environment, decision makers have at their fingertips the live stream IoT data, defect analysis with automated intelligence, and all of the BIM data, photographs. And so they can really get a complete picture of what's going on at the structure to make sure that they're making the best possible decisions possible.
Yeah. And as Taylor mentioned, one of the strategies we involve in the IBR program is to do a full corridor reality mesh. And really that served as an existing condition model for the IBR program that included photogrammetry scanning of the existing I-5 bridge. But really that is a way for us to spatially connect data as well as plan our sensors for the program, because that provides kind of the existing condition model. And then our design models sit on top of that reality mesh and integrate into that environment.
Yeah, it really sounds like the benefits are very, very much made tangible on that kind of project, given how, in case any listeners don't know how congested it is, and the fact that there's an existing bridge already there, which is, I believe,
Yep.
an 11-span steel truss structure with one movable span as well. So I was going to ask you, Tom, actually, whether a reality mesh had been created with that existing bridge. Did you use the helicopter to create that reality mesh? Sorry.
Yes, there was a photogrammetry scan. We chose a solution that was done by helicopter. So this area is near 2 airports, and so has restricted flight due to drones. With a helicopter, we were able to use a solution that could fit within the flight planning of the area to do the capture efficiently. That capture was also done at about 1,000 feet versus aerial reconnaissance or other types of data collection. So it gives a very high resolution of that reality data over the program area.
That's amazing. Okay, so we've talked a lot about gathering IoT and asset-specific data to develop a digital twin for a bridge that's being constructed. Designed at the moment. Circling back to the structurally deficient bridges in the US, how can digital data be leveraged on existing bridge stock?
Yeah, well, again, with WSP, our thinking is transitioning to model-based development for existing bridges. We want to look at how we can use reality scanning of those bridges to perform inspection analysis, as well as look how we could quickly develop models so we can connect those models to a data schema, the asset management side of bridges, so we can get a complete picture of an existing bridge or project. Traditionally, many of these activities were done in silos by different groups. By using these tools, we are building a collaborative environment with our teams between asset management teams, as well as design teams and other aspects of the program. So again, how we can advance building that data for existing bridges is kind of very critical to our industry and our program.
Yeah, and we've touched on bits and pieces of it already in the discussion today, but just going into a little bit more detail, there are, as you mentioned, a lot of structurally deficient bridges out there in the United States that are in poor condition, and the use of these technologies can again help agencies make better decisions to ensure that they're spending their money and their resources in the most critical areas first, and hoping to prevent potential issues down the road by, again, using that data efficiently. So again, drone scans on the existing structures and the use of AI/ML capabilities can help agencies basically take the bridge structure that's out in the field and kind of bring it back into the office, so those decision makers can see exactly what's going on in the field. The use of this digital twin technology is a great benefit for augmenting inspection activities in the field, so that you can, one, reduce the amount of time spent in the field, hopefully mitigate the need for additional trips out to the field by, again, being able to make or being able to use that reality mesh in order to make decisions and gather additional information back in the office, saying, hey, we see that this is going on. We forgot to look in this particular area, but I think this would be of concern. Maybe we can just pull up the reality mesh and take some measurements or see what's going on in this area, maybe instead of having to go back out on site. And then again, the use of IoT data on structures like this, particularly we've seen a lot of use in the scour area. So for those not familiar, scour is basically the movement of water under a structure or through a structure that could be potentially undermining, eroding dirt and undermining the structural integrity of the installation. And so IoT devices can be utilized in order to augment those types of underwater inspections that take place on structures like this, so that instead of relying on an inspector going out there every 4 or 5 years, as typically is done, IoT devices can be installed proactively to monitor things like scour erosion on a structure. And when there's things like flood events happening, again, you can get real-time data back in the office to know whether or not anything of particular concern is happening at those structures. And again, it really enhances the decision-making capability of asset owners.
Yep. And what we're really trying to create, and with these tools, is in essence the metaverse for an infrastructure program. Because as Taylor mentions, we want to test and understand the interaction of data in these projects well before we put our design solution in place. Because that alone could potentially solve many problems, as well as create the opportunity for cost savings through the implementation of the IBR program.
Well, it sounds like some huge time and cost savings are to be had with the implementation of this new technology. So I'd like to thank you both, Taylor and Tom, for joining me today. That was a really enlightening discussion.
Thank you.
Thank you.
Thank you.